All right. Recording in progress is what it says. It is 2 p.m. on the eastern seaboard. Brant, that puts it at what, 11 a.m. over where you are?
Correct.
Oh, Dan, what time is it at your home?
I got noon. I'm in the mountain time zone.
Oh, we are spread. I don't think there's many time zones left to discuss, Kit. Where are you?
I am also on the West Coast. Brant and I live like 20 minutes away.
So this Eastern time zone here is just for our OpenSSF organizers who made the slide. It's not even for us, as I'm in Central. So we are going to start the actual content in about 2 minutes. 2:03 is going to be our content start time. Super excited about this. If anybody's joining us from around the world at less convenient times, I want to say thank you for joining us. Super excited to talk about this. Um, and beyond that, we're just going to be kind of hanging out for the next 2 minutes to give everybody a oh, we got chat active. Eastern time zone is present. They're present and represented in the chat. That's awesome. Dan, I do need to know, for confirmation, you have not been a victim of like Honey, I Shrunk Your Kids or something. Like, because those grass blades are very.
Absolutely, man. I'm gonna be climbing up the grass blades here. Just wait. That's part. You don't steal my thunder.
Brant, you don't seem to be walking right now. Do you have your treadmill turned off or?
Treadmill is turned off. I took a poll and people found it distracting.
So for webinars at least, let's let's have it all. Uh, Kit, you're not on a treadmill.
No, I like my chairs. I tried like typing and using a computer with a standing desk, and it was just like it was too much of a paradigm shift. I had to sit back down.
Yeah,
It's
yeah,
got to take practice. I can't do it. I can't stand and or walk and concentrate.
yeah. The walking part throws me off. I could do it for meetings,
Mhm.
but to Brant's point, some people don't appreciate that. Yeah. All day.
He's always walking. We'll have like a team meeting. He's just walking.
I do like if we're like out at events and stuff to just like take a walk around the block or across the convention center. Moving while meeting is always nice. My clock says that we are at 3 past the hour, so we are officially in the content mode. Thank you for joining us. We have a Zoom Q&A feature. If you want to guarantee that we get to your questions at the end, use that. I believe chat is active, so if you want to just banter, absolutely use that as well. Um, OpenSSF does have a pretty robust social media presence. If you want to stay up to date with things such as this that are happening, get project updates, all this cool fun stuff, be sure to click on those different links. Also, OpenSSF has been making a massive push this year to put out training content. Do check that out. Some of the training content is let's just say getting very, very good responses, not just in the number of signups, but on the outcomes that are getting produced there. This recording will be available later on. So if for some reason you need to abandon us to speak into the void, you can go to the void later on and pick up this recording afterward. We're going to do intros here in just a second. After that, we're going to do a little bit of a round robin where you guys will not be subjected to the torture of my voice, but you will get to listen to the wonderful harmony of our three primary speakers here, Brant, Dan, and Kit. And after that, we're going to go through Q&A. I've got some questions that I am going to prioritize because I am significantly more important than anybody else. But going to only do a couple of those, and then I would really like to be hearing from other folks things that stand out to you. If you want more information, shine a light on something, kind of double click in for more details, drop that question into the Q&A. If there's something that you think wasn't addressed, bring that up as well. Read this. It's a lot of words, but everything that we do in the Linux Foundation is falling under an antitrust. Follow your local laws. That's the big rule here. Also, this mostly applies to the chat and the Q&A, but also for the speakers. Hey guys, like be cool to each other, be kind. They Foundation reserves the right to take corrective action as needed if you are not cool. And then Q&A, don't forget to do that. There's a little picture of how to do the Q&A so you can make sure that you get your stuff focused. Now on to intros. I'm going to run through this and then we're going to hand it off to Brant. My name is Eddie Knight. I am the OSPO lead for Sonatype. I also chair the technical oversight committee for Finos. I'm a security advisor with Brant over in the CNCF. And like Brant, also a maintainer in the OpenSSF. One of the things that I'm really, really excited about today is to hear about the airgap focus of Zarf. For my experiences, the designs that I've been looking at Zarf for, it's very much just on generic software delivery, packaging things, using OSI registry as a mechanism. Those kinds of features that Zarf does in a very generic sense are things that I'm really, really curious about and have been exploring. Sonatype, my employer, has been looking at Zarf for airgap situations. And so I'm super excited to hear more about that from the speakers here. Brant, pass it off to you.
All right, welcome everyone. I'm Brant Keller. I'm a software engineer at Defense Unicorns. I'm a technical lead for the Zarf project, but also just more broadly, a maintainer within the OpenSSF and the CNCF. CNCF ambassador, a technical lead for the tag security and compliance at the CNCF. And, kind of in that same vein and, across the board, been working on authoring other publications for Kubernetes GRC, automated governance, and kind of other topics related to supply chain security. Some of the stuff we're going to cover today. And then my background really, kind of post-military career has been working with state and local agencies on various software capabilities, working within the defense industrial base on, kind of a lot of this air gap problem statement, and then kind of transitioning a little bit to broader public sector support and finding ways to kind of bridge the gap between open source and public sector and kind of improve the ways with which we collaborate.
Kit, you want to take over?
Yeah. Hi, so I'm Kit Patella. I also work on the Zarf team with Brant at Defense Unicorns. And in my career, I've worked on open source systems a lot, often with the benefit of like a sponsoring company. That's what I do at Defense Unicorns. I'm actually new to air-gapped use cases. I come from an enterprise background and doing stuff like infrastructure, ad tech, mostly product development though, and open source. Kind of been fortunate enough to work on a lot of different systems. And I've also worked as a consultant for database companies doing distributed systems analyses, breaking machines that are networked, and that's a lot of fun. But I'm happy to be here, and yeah, I live in Ballard, Seattle.
Dan, last but not least.
Hey, thanks, Eddie. I'm Dan Miller. I work for Boeing. Been there a good long while and been a software engineer my whole career. Started out really deploying tool chains, development applications so that I could do my own job, and then kind of moved into the DevSecOps world more recently. And even most recently been deploying into closed areas. So that's been it's been a learning experience, what works best, what works well, just to give, everybody, equivalent tooling so they can do their job software engineering wise. I live in Colorado, so all the fun things when I'm not climbing the grass blades behind me, I'm out mountain biking or taking a hike or doing what I can outside. Thanks.
We have a comment from chat saying that you are one of Boeing's best and most modest engineers. So that's a little,
Appreciate that.
a little vote of confidence there. All right. Last reminder, I saw some folks have been joining in the last couple minutes. Use the Q&A feature. We are going to be tapping into those questions. You're also welcome to use chat throughout to just kind of banter. Brant, can you just kick us off with the high-level intro to everything that we're going to talk about today?
Yeah, I mean, kind of to really set the stage here. There are a lot of challenges with working with air-gapped software delivery. Not all of them are solely isolated to air-gap. You'd be surprised how many of them kind of overlay to connected systems. Next slide. But a lot of this, whether it's offline or it's ingress, egress constrained, becomes at first glance, maybe seemingly trial and error. You try to figure out, do I have everything I need to run in an offline environment? oh, hey, I don't. What next? I go and grab that thing and try to figure out the next dependency in the chain. There's a lot of reasons why this is not a recommended best practice, and we'll get to that. But case in point is really like tool chains and their composition, right? If we took a look at CI/CD, scanners, SBOM generators, and registries, they really all optimize for the connected user experience. You want to deploy something out of the box, things like image pulling, license checks, updates for the applications themselves, and in something like CV feeds, which is very prevalent in these environments. They all kind of tend to default to reaching out to some managed service. And this is often a non-starter for an air-gapped environment. And more often than you think, making these configurable isn't always an option. We have to, look at what tooling is available when we want to build for these environments, and that isn't always as ubiquitous as, say, the landscape of applications generally. We look at supply chains and really the sprawl involved with not only the platform itself, the ways with which you're developing, but when you're developing in these environments, it takes it more to a more granular layer. You have modern apps which are built in these environments with tens, hundreds, thousands of transitive dependencies. Each of these has to be mirrored. We have to look at things like how do we govern them? Are they signed? Are they scanned? And what does that mean? And in particular, not only what does it mean, but how much of this can we evaluate before it crosses the boundary? And this is what I was talking to earlier, that this boundary exists between your connected environment and your disconnected environment. And optimally, if we're doing, secure software delivery, we want to catch everything that we can at the packaging phase. We want to make sure that we can check for any malicious material, anything that may be non-compliant with the way we operate our environments, and catch that before it actually enters these environments and then potentially makes our lives harder, or we need to go back and mitigate or spend additional time scrutinizing. Identity and trust, whether it's user identity or machine identity, SSO and short-lived tokens become very explicit, and something as seemingly trivial as time synchronization can end up stalling what you're doing. You have to go back and you're trying to debug something. You have no idea why it doesn't work. You can replicate it working in your connected environment, but doesn't work in your disconnected. And you find out that there are very much hidden dependencies way down into the depths of your system. Patching and kind of the paradox involved with you need to patch fast, but patching is introducing something to these environments, and so we have to validate it. And we look to that boundary we mentioned earlier. We have to look for areas of how to really optimize the scrutiny, lower the surface area of what it is we're scrutinizing, and kind of look for the deltas of things that maybe we've already scrutinized before, surfacing priorities. Observability blind spots, error reporting, and remote logs cannot egress. And so you need this on-premise self-contained telemetry from the start. It's not something you can easily bolt on because often the requirements are really embedded for these environments. And, we want to kind of capture those resource requirements from the beginning, as opposed to finding out that we need, to bolt on large parts of infrastructure just to support new parts of the system. And so those are constraints that we have to think about way back before we even get to, building these systems. And then finally, kind of working to reproducibility and provenance in the security domain. Regulators or, possibly those who are approving the artifacts that enter these environments, they really want kind of a provable lineage, right? If you're rebuilding these artifacts in an enclave, then the same inputs can be really hard without consistent packaging of bringing everything you need to, create that provable lineage. And finally, human factors, right? If the approved path is slow, people are going to find ways to circumvent those paths. And, we need to not only create appropriate guardrails to prevent that, but also, try to really define how is our infrastructure managed declaratively, and what does that baseline mean for us? Next slide. Some of these examples I think are pretty straightforward. Public sector, financial, healthcare, other government related services, We see this often with like FedRAMP and some of these other, I'd say, compliance related offerings that people go through in order to get their services available. These exist, and if we think of even most of the like extreme cases that I'm not going to delve into, they're air gapped for a reason. And so there's, very critical pieces of infrastructure, whether it is extremely air gapped or semi-connected, or parts of the system themselves are air gapped where others are not. Like this is a spectrum that we have to operate along. The defense industrial base, and we think about classified environments or environments that are building capabilities for national security, are very much at an ends of ensuring that they are appropriately air gapped from public networks. Sovereign cloud, I think, is a really interesting one because it's becoming more prevalent. But anybody looking for digital sovereignty is going to be thinking about these problems. What managed services do they use? Where's their data stored? How do they operate? Where's their compute? And they're going to start to look for, kind of a leaning into where's the locality of all of that, and what services do they need to bring back to their systems, and do their applications support that? And it kind of revolves back into the air gap use case. And then finally, enterprise, right? I think all enterprises at some scale start to integrate internal managed services. And these are, going to be attempts to, try to capture their egress from their corporate networks. And instead of just denying all of that, they want to find other mechanisms for proxying things appropriately, scanning things, allowing for maybe some of these additional guidelines or, workflows, quality gates to be put into place. And really what we're talking about is like creating pockets of air gap. Where is it necessary? Where is it not? How do we want to handle these things? And again, what supporting infrastructure is available to us? Because maybe that's not ubiquitous. Next slide. And kind of separate from that, but in the same vein, it becomes very prevalent to start to look at the risks of assuming constant connectivity, right? Tools or processes assume that connectivity, and they have it, and otherwise they may or may not have a fallback mechanism. What happens when something cannot connect to a data source that it needs or a managed service that it requires, and does it fail gracefully? Optimal scenarios, yes, it does. That is not always the case. And how is it, kind of evaluating what to do next? Is it caching things? Does it have an offline, data source mechanism that it can either A, fall back to, or B, treat as the primary data source? And so these downstream processes that are dependent on those systems now lose their capability, right? And this kind of creates these cascading impacts across your infrastructure. Security drift, we rely on a number of upstream sources of truth, and many of these can silently fail. I want to kind of emphasize that point, silently. It could be CVE data, revoked certificates, expired signatures. They create these, silent trust failures where operations continue. You're not aware that something maybe is out of synchronization, but otherwise you don't have the most up-to-date data. And the easiest example for these is always like the CVE feed. If you're scanning your environment continuously for vulnerabilities, you're scanning your software continuously. Where is it getting that, source of the CVE database from, and how? And, is there a risk that that becomes, out of date? You don't have the latest up-to-date information. And I think that's kind of always prevalent. There are ways to circumvent that and get ahead of that. But it becomes very explicit in the kind of the mindset or model that you need to apply. Infrastructure dependencies, we kind of called this out earlier, like image pools, operators, and kind of their integration with internal and external services, policy management, data management. We've gotten very good at making our architectures distributed, while also creating dependencies that are reliant on these threads. And so in a scenario, something is such as like a fail closed, your policy engine is evaluating something, could be, Kubernetes based, it could be infrastructure based, et cetera. If it has a fail closed mechanism and it can't reach out to that external policy, maybe you have it stored in OCI, How does it respond? And what does this mean to you for your infrastructure and your workloads? Are you now facing like partial outages? Something that you want to be very forward thinking about. And finally, kind of your threat surface area. Where could somebody maliciously, try to degrade a dependent service that affects your infrastructure? We got these registries. Where are you pulling all of your images from? Do you have a countermeasure for your production workloads and scheduling to, kind of enable them to still pull images in the event that the registry you rely on is facing an outage, whether malicious or otherwise? It is very prevalent. We've seen this many times. Have you enumerated all the sources of ingress or egress from your system? Do you know which ones are phoning home, even if it's just for like capturing some telemetry about, how you use the app and not doing anything nefarious? But just kind of enumerating all of those and then really pushing for security by default is often not the goal for all of these applications off the shelf, especially open source. They kind of cater to the widest user base and that user experience of how can I deploy this easily and see that it functions and does what I need. But more often than not, we're applying hardening to those. We're explicitly opting into a secure by default or more secure stance. And less times the requirement is loosening the security guardrails. We don't see that as often. And so it is very, kind of prevalent in how are these applications configured by default. With that, I'll pass it over.
Yeah, hello. So we've got a quick tour and demo here of the Zarf packaging workflow and what it's like to deploy those to show you how Zarf simplifies all of the challenges that Brant just talked about. So on the next slide, the magic of Zarf is really in the create and deploy lifecycle. Zarf allows you to pull in everything that you need into a single tarball. And what we're really going to zoom in here is what it is like to build the tarball and deploy it. So both as a creator and a deployer. And that has a lot of benefits. So up next. These are really our two persona, and just what we build Zarf around is what the creator who works in a created environment or a connected environment, excuse me, and then the deployer who works in the Airgap and has a lot more restrictions. So for creators, you get a declarative versioned package format and a quick feedback loop where you can iterate and deploy locally into a simulated Airgap. But you still have access to all of like the resources you might need, like dependencies to download, app updates, docs. Meanwhile, in the Airgap and the deployer, you really just need one thing at the end of the day, and that's working software. And Zarf's package format and the system optimizes it so you get reproducible results. You can take that same artifact and launch it again. If maybe you configured your system to have a read-only disk, that's fine. Fix it, launch it again, no problem. And then next up. So a Kubernetes cluster has all kinds of dependencies, right? You've got Docker images, you've got configuration descriptors like manifest charts, maybe Git repos that you need to clone in, or sometimes you just need a file or to run a shell command. And Zarf has ways to abstract all of that. Next slide. So each of these dependencies gets described in the package definition. And if you work in Kubernetes, you're pretty familiar with YAML. And we'll take a look at what an example of that is now. And so you specify it, you package it up into a tarball, and then that is your deployment artifact. So taking a quick look, you can see we have a package config. It's got a name, version, all pretty straightforward. You can specify a chart, what version it is, including like helm values files along with it, maybe a specific image that you need. So these are all just things that you can describe or dependencies that you can describe in your package tarball. And then up next. And one of the benefits of having this declarative package structure is that you can get a bill of materials of what you produce at the end of it. And we use SIFT to encode all of that. And if you take a look inside the package, there's a nice little navigator to go and see what is in your bill of materials. So as a creator, you've got your fully connected development loop. You iterate and you build these Zarf packages that you get to test locally. And then Up next, you get that tarball over to your like delivery persona. Could be you, could be another person working in a skiff. I learned the phrase sneakernet recently. If you have like a DVD or some kind of removable media, I think that one's pretty fun. And up next, you're in the air gap. You get, as a deployer, you run Zarf package deploy with the tarball, maybe several, and you get a simple deploy, runs through everything that's described. And again, the point is just to have working software inside the air gap. And like, look how happy that guy is. I won't be happy. And there's advantages to this model, even if you are like both the creator and the deployer. You know, it's not necessarily just throwing packages over the fence. Where when you are in an air gap, you have just significantly more restrictions. And so getting to develop and figure out everything in a connected environment just makes your life so much easier when you actually do have to ship it. Okay, so I'm going to give a quick demo of what this looks like. And I'm going to share my terminal. And so here we're just in Zarf main. I made a little demo branch. But if you take a look at, let's see, just Zarf examples. Oh, it's because I'm in examples. If you take a look at Zarf examples, you can see that we have all of these different use cases. And the one that we're going to look at is just a fun one. We're going to take a look at the DOS games example. Cool. So if we look at the package definition, like the one I showed earlier, you can see name, version, description, all very simple things in metadata. But we also have this component, which describes the Doom game image, and then has a very simple deployment and service. So what's it like to create this? Well, if we go to Zarf package create and take a look at the logs, you can see that we fetch an image, pull it down, save it. We generate an SBOM from it, write it to a tarball, and then you're pretty much good to go. And there's nothing like magical about this tarball, where if you go and just take a look at the tree of the included files, you see, okay, there's our SBOMs, checksums of files, right? Like it's an open format. It's not some proprietary system that you're locked into. Once you have the Zarf package, you can always inspect it and take a look at the data. So, okay, cool. We've created our package, we've iterated on it, and now we have our software, which we know works locally. Let's say we're in the air gap now. And this is usually the part in demos where we turn off Wi-Fi, but as you can imagine, while streaming, that poses certain challenges. Let's just use the theater of the mind for now. But as a batteries included system, we have kubectl included. So if we take a look at the pods, you'll see that, okay, we have the core Zarf services running that make it possible to run this stuff in an air gap. And then just bog standard Kubernetes deploy. So if we do Zarf package deploy, it's going to show us same configuration data. And then a lot like create, we're going to go through, unzip it, and then, yeah, we can connect to the package we just deployed. And just so we can see, we list the package, we can see that DOS games has been deployed. And if we list all our pods, we should see it there as well. Yep, there we are. So we're going to use the tunneling system to connect and connect to Doom. And then I'm going to need to screen share a different window. So hopefully I can do that quickly. There we go. Can everybody see that? So this is very, very businessy. Have all the software that we need in the air gap. And it looks like we have a minute or two here. So I might just, okay, I'm just kidding. I can hand it off from here.
Cool. So I think that is my cue. I will be going through some somewhat real world examples, kind of use cases of how we've used Zarf, challenges, kind of the evolution of how we've done the work that we have to do. So starting out, and this was, I guess, before Zarf BZ, we were really trying to do everything manually and creating a packaging structure everything that we need, all those things that Brant was talking about earlier, trial and error. We need, some image to run. So let's bundle that up into a manually created tar. Next, we need some configuration docs. Well, let's go ahead and add those to the tar. Next, we're deploying to Kubernetes, so we're going to have some sort of a Docker registry that Kubernetes can pull its images from. So let's figure out how to do that. And so it kind of just, not to downplay it too much, there was a lot of work and engineering that went into doing that right. But there were a lot of extra pieces, a lot of just one-offs that we had to really kind of throw together in somewhat of a custom fashion, and figure out all those little pieces that we were doing. There weren't by default manifests included. There weren't SBOMs created. So those were all extra individual manual steps to move beyond making the package for a air-gapped environment. And so a lot of those things were a little bit bootstrap, having to set up external cluster resources, Docker registry may be running externally in Docker on a different machine. So a lot of work went into that. Custom Ansible scripts to, push everything where it's supposed to be. Custom tools, Scopio, and just to warn everybody, I'm going to be name dropping a lot of different tools here. But those are interchangeable things that we can add in, change out, remove pretty easily. The whole CNCF kind of landscape here. Once we realized and saw and started making the connection of Zarf and the Defense Unicorns team developing that, it became pretty obvious that this is a super powerful tool. We could be doing almost everything that we're doing with custom scripting, manual processes, and have an even better solution that's declarative, using YAML recipes to group all these things together. So we made that shift, and it wasn't easy. Nothing, no changes in life are ever really easy. But having a tag up, having some tech meetings with the Zarf team themselves really jump started us into getting to a point where we were comfortable with the Zarf tool, and starting out with the examples that Kit mentioned before led us into being able to use the tool really easily, packaging up all the different types of resources that we're going to need. Pretty much exclusively, we're deploying to Kubernetes with Helm charts. But in addition to those Helm charts, we need the values overrides. It makes it super simple with Zarf, as Kit showed before. We're going to need some configuration files, and we may need a Git repo, packaged in. We may need some binary tools to help us in our deployment, our troubleshooting. Some of those are Zarf bundled, and it's pretty amazing the individual applications that we either had dependencies upon, had to bundle up ourselves, have teams in the air-gapped environment get approved, transfer themselves. They're in Zarf now, and you can easily do a Zarf, Zarf tools, Zarf dev. Just use the application. Great help system built into it to see what's there and what's not. As Kit mentioned before, kubectl bundled into there, a subset of the Helm operations bundled in there, so you can see what's going on. Registry, inspection tools, SBOM tools, all those things. So when we got started, and again, I guess I apologize for the slide that we're looking at. It's really not intended to be understood and seeing every part of it, but it's really just a generic of there's a ton of tools that we should be deploying for a software development platform, internal developer platform. And so all of those tools need to be bundled in, transferred, analyzed for vulnerabilities, all the things Zarf and Brant and Kit mentioned on before. So we take those tools, bundle them up. First thing you think about is the images. There's a section of the Zarf YAML to easily bundle in the images. Next thing is the Helm chart. And hey, there's a tool to figure out based on the Helm chart that you're trying to use what images you might need. Zarf handles that. Just ask it to inspect your Helm chart. It'll tell you the images that you need, and no brainer, pop them into the YAML file for inclusion there. But yeah, like I said, if there's additional binaries, adding those in with a manifest, a checksum, so you're getting exactly what you're intending. It's not being changed anywhere along the tool chain path. Super easy to do there. So we made the switch from totally custom, bundled, and deployed solution for IDP to using Zarf almost predominantly for everything now. So a way that we've structured it and architected is that every application has its own Zarf package, but Zarf also allows you to push skeletons and then bundle additional packages, a Zarf package of Zarf packages, or an Uber package, if you will. So that's kind of how we're bundling it, architecting what we need to get into the air-gapped environment. Once that's happened, we didn't have to use a lot of the custom tools, the onesie, twosie tools. We're using predominantly most of the Zarf bundled tooling that it just comes with out of the box. The next step of that is, so Kit showed the bundling up, the creation of a Zarf package. We're doing that, and potentially, Zarf bundles of Zarf bundles. And as Mark said in the chat, yeah, like a Zarf orchestration of the different packages that we need. In addition to that, all the variables that can be broken out with, just built-in Zarf capability are being put into a configuration file that the deployer will use at deployment time. So, anything that you can imagine that needs to be variabilized out, that would change environment to environment, we have into a sample configuration file that'll be used during deployment, and teams can update those values as necessary for their environment. So bootstrapping on the deployment side, getting Zarf into an existing Kubernetes cluster is really cake. It was what it comes down to. Instead of having to create external dependencies for a registry, customize your Helm chart values, any other configuration values for what is specific for your environment, Zarf is covering. You bootstrap your Kubernetes cluster, push your images into that internal Zarf Docker registry. It's mutating webhook, Zarf agents, handle rewriting where the images are being pulled from if you're in that environment. So a lot less steps for developers and testing on the outside of that air gap to get right. It just handles it. So we've been able to use various different various different Kubernetes platforms. RKE2 is one of those. We've used Tanzu from VMware, EKS, in an AWS environment. Soon, we'll be pushing to AKS, hopefully in Azure, as well as Zarf. Actually comes with its own Kubernetes solution platform. You can deploy K3s by default with just running a Zarf deployment of it there while you're bootstrapping. So we've used kind of across the board. It's just worked well out of the box for all those things. Stepping back to a developer platform, there's a lot of tools that you might have access to in a internet connected cloud environment. AWS services like a database, like block storage, EBS, EKS, the Kubernetes deployment, all kinds of different services that you would have there. Those are definitely things that need to be kept in mind as you go to the air-gapped environment in a non-cloud environment. Honestly, some of the Zarf examples that that are listed out on zarf.dev are what we base some of our opinions on. The cloud native landscape was really kind of what we ended up with making a determining factor on the tools that we used. But those Zarf examples helped us along the path. Longhorn is our replacement for an EBS data store persistent volume, storage class. MinIO, as an example, replacement for S3. A lot of those things in those examples were on the Zarf examples set, but then going back and checking the CNCF landscape of what's most mature, what's best tool in that environment, and taking a look at what makes most sense is helpful there. So I know I'm reaching a bit of my time. So getting started was really with Zarf was really, having that interchange with them, the team getting involved in their Slack channels, getting involved in the project in GitHub, having the conversation about something. I either don't know how to use it. How do I do this with Zarf? And that feedback came just immediately in the Slack channel. If there was something that we as a team needed or wasn't working for us, if it was release to release or just some capability not in Zarf yet, pushing out a request in GitHub, making a new issue, having that conversation in Slack to see if there's some other way to do it. Super responsive, and those updates and capability came really quickly as we moved on. We've been using Zarf for a good number of years now, and so it's really helped. Having that direct interaction with the Zarf team, being able to get in and get our hands dirty, which we haven't unfortunately done a whole lot of contributing to the project, but a lot of comments and feedbacks, a certain amount of bug feedback there. It has really helped us, help the Zarf team help us, and help others, the whole community of those using Zarf. Some of the gotchas, I guess, in using that have been, I mentioned a few of the bugs that we had feedback. Some of those are just from upstream dependencies of Zarf, mentioning that it's including, a good number of utilities, Helm, SIFT, SBOM, conversion tools. Those have caused us a bit of issue, but being able to revert quickly back to a working version of that's bundled into Zarf, has almost been a no-brainer. We're talking quick turnaround, so that's been awesome for the team. The tooling, security-wise, the tooling that allows you to inspect a Zarf package, pull out the SBOM, and then run that through a analyzer like Gripe, or we're using a tool called HopperCop, which is community created, produced by I think another contractor in the defense sector, but it's been great. It'll produce, it'll analyze those SBOMs, produce vulnerability reports with a few different tools there. So great tool there in collaboration. I guess a couple things that we've gotchas on Zarf. Otherwise, customization works a little bit differently. That's hit us. Again, not to dig too deep into individual things, but just because of the way that you're packaging up in an internet connected environment, and then going over to a disconnected air-gapped environment, you don't have the exact same operation of things like customize. So in addition to a few of the other those challenges that I just mentioned, really deploying into an air-gapped environment Zarf has taken the difficulty of packaging out of that. Then you're still dealing with a lot of the other situations where you have to get approvals for software, you have to transfer that software, sneaker net it, or whatever your mechanism is to get a package from the internet connected side to an air-gapped side. That turns into organizational kind of processes and difficulties there. So, those are always going to be remaining prevalent, but all the tools are at your disposal. By providing SBOMs, by being able to analyze those, being able to inspect, once you go to a air-gapped environment. So it's really become such a powerful tool for us that that's really the way that we're bundling everything, whether it's a application deployment, all the configuration files that go with it, or if you're just simply transferring libraries, it's super simple to do and efficient to do with all these extra tools that support all that, using Zarf. I think I'm at time, so let's pass it back.
That was really, really, really good. First question, something you brought up very indirectly, is that you're openly using Zarf and interacting publicly with all of the maintainers, in spite of the fact that your organization is definitely a highly regulated institution, right? Could you share anything about like that journey? Was it a no-brainer? Like, did you have to go through any hoops? Like, do you have anything that you can share about how you got to the point where you can be working in the public and sharing feedback so openly the way that you have been?
Yeah, that's a great question. And you being lead of the OSPO organization, our organization, our OSPO organization, is really kind of in the last couple of years really led that charge. We became part of the CNCF. We had a lot of thrusts and a lot of developers wanting to be able to get involved. So that's from that standpoint, you're using an open source tool, and every software organization is using that. The fact that it is an open source tool, you have attribution of all the code going into it, who's committed those things, um, as well as we're so heavily reliant upon that. It makes sense for us to be involved, kind of helping guide where the tool goes, fixing things. So it's been honestly, it's been a bit of a challenge, just getting that mindset where this is a tool that's super valuable for us. We're using it, we're dependent upon it for a lot of different things. Let's help make it the best that we can make it.
Cool.
And
Yeah.
it's gone up through management. Yeah, it's becoming more prevalent in the organization.
Yeah. A lot of air cover to bring you to this point that you're at now.
Yeah.
Cool. Okay, so Brant, I think this might be a question for you. Anybody else can chime in if you have stuff. But could you, maybe you've already done this, but could you walk us through a little bit of a persona activity of like who's an example person, right? An example human. What role do they have where Zarf would be a no-brainer, or even just helpful, like something that would solve active problems for who?
Yeah, I think one of the core personas involved here is something that we're going to see hopefully an evolution of for Zarf over the next, year plus, is really somebody who's trying to capture and abstract a lot of the secure software delivery problem. So the Airgap use case is a no-brainer, as far as like how do we bootstrap things? How do we solve common problems of like how do you deploy a registry without having a registry to pull the registry image from? Those are all really fun in the very straight line problems to solve. But when we think about like what a Zarf package really is at its core, is a mechanism for abstracting everything your application needs to run, and including the batteries with it, right? If we're talking about a Helm install today, a Helm install for any application that you go and find in the open source is really no different than running like curl bash and installing some unknown binary on your system. You don't know where those artifacts are coming from. You don't know what they're comprised of. You don't know what they do, or that they're going to do what they say they do. But for Zarf, it's really kind of like that. Take that feedback mechanism for the create, retrieve everything you need to run in the extreme of the offline environment, but again, just to remove your dependencies from those systems. And so again, digital sovereignty I think is going to become, a big part of maybe why Zarf might be considered. But then just get back to abstracting that core use case. How do we make supply chain more, of the default package application lifecycle, and make it so that we do SBOMs just out of the box. People don't have to think about generating their SBOMs as a secondary activity. How do you sign things? What are you signing? How do people verify when they're receiving your artifacts? And so I think there's personas in this domain of just secure software by default, that is going to be very relevant.
Cool. That's helpful. Thank you. Okay, extending that from the person to the organization. This is gonna. I'm gonna be silly with this. If you could all three give just like a single answer to this, and then I'm gonna rate your answers and see which one I thought was the most bestest important one. What is a what is something that an organization needs to believe before Zarf will solve their pain points? Philosophically, right, and understanding. What's something that an organization needs to believe before this would become useful?
Yeah, man, Brant, you got your hand up. Go for it first.
I think for me, it would go back to, um, I think the simplicities of, do we want to write it ourselves? Are you a shop where you build it yourself? And if you are, awesome. Like if you're already doing air gap use cases and you've got your tool stack, wonderful. We're not advocating for you to change from those, but more, what is the consideration you need to make when it comes to maintaining that in perpetuity?
Yeah, I'll say similar. And I should have gone first because that was definitely going to be my first one. Do we want to reinvent the wheel? Do we want to, use something that's, potentially used by a lot more customers than just us? And let's analyze, what capability is in the tool and see if that covers, X percent of, what we need or what we didn't even know that we needed, and hadn't thought about yet, but it's already there, capable in the tool.
The main question that comes to mind for me is like, is the time and happiness of your developers, of your engineering staff worth investing in?
Okay, that one wins. Like an organization needs to believe that making their engineers' lives easier creates value. But then you also need to believe that it's worth it to uh, bring in outside tools to accelerate instead of maintaining it yourself. If you believe that it's better to maintain your own tools, Zarf isn't going to seem valuable to you. And if you don't
Yeah.
particularly care about helping your engineers, then you're not going to change the way that you do business to help them. So that's cool. Thanks, guys. Question from the Q&A is, I'm going to read it verbatim. Is every tool has limitations? Is there any air-gapped use case or edge case that you've found where Zarf is not recommended as a solution? Because it sounds pretty great so far. It's from Mark. Any place where Zarf would not be recommended?
Well, I think not knowing, maybe as broad of a use case as the Zarf team itself. Um, Obviously, I think it goes without saying, but you really should have, it shines when there's a Kubernetes platform to deploy to. Obviously, you can always use it to bundle things, take them to the air gap, but I mean that's the real intent of it when you have a Kubernetes platform.
Anybody else want to add on to anti-patterns or anti-examples, anti-use cases?
I think Dan and Alan in the comments really nailed it. It very much optimized for Kubernetes. We've explored other use cases for, when does it make sense to do something with Zarf for sake of like Docker Compose and infrastructure that maybe doesn't need the complexity of Kubernetes. But at the same time, kind of ruled those out for sake of scope on like what things do we want to solve for at its depth. And there are ways with which you can use any tool to maybe accomplish the job. And you could certainly do maybe compose like activities with Zarf, but it's not too optimal. You're kind of shell scripting at some point.
Cool. Okay, last question, and then we're gonna just kind of start wrapping up here. Uh, what's the difference between using Zarf air-gapped and using Zarf in a just like fully networked environment, non-air-gapped?
Something that we see is like mixed connectivity environments. And this is like very common in enterprise, right? Where you just have an allow list of ports and services that you're allowed to access. I think that's actually a really compelling use case for Zarf, where you get to kind of not necessarily like ignore those constraints, but set up everything that you need for your application in the most optimistic scenario, and then just not have to worry about it. It's optimized for the most restrictive cases, but then that also means you get to skip all of the complexity of whatever your org decides is important for your network settings. And it's always business specific.
Ooh, I really like that. I want to hear if the guys have other answers, but just like the thing I like about that answer is when I was working inside the banks, there is so much that we had to worry about with firewall rules. And if we could do everything ahead of time, instead of being like, okay, here's the wild, wild web, and then here's our green zone, and here's our amber zone, and here's our red zone. But if it was a single activity all the way through, then it would just dramatically simplify a lot of things. So that's yeah, that's a really good point. Did you guys want to add anything else, Dan or Brent?
Yeah, I'll jump in, and I think it's a way of like, you know, looking at the problem from various different layers of what you want to solve for. Again, if you can move your developer base and kind of provide them with a consistent baseline, maybe that assists you, whether you're deploying to Airgap, maybe whether you're deploying to connected. If you can maybe centralize and standardize on tools, potentially there's some benefits there that'll make your lives better, and support the developers better. But then also when you compare again, what is Zarf doing and what things can you kind of like opt into? Hey, you want more resilience around the ways with which you are caching images, and caching uses a very broad term. But you can, deploy Zarf in a connected cluster, right? You already have workloads deployed in there. They pull from wherever they pull from. You can deploy Zarf alongside those, and kind of bring along like, okay, which of these are our core infrastructure workloads. We want to make sure that they do not go down because everything else around them is dependent upon them. Maybe you set aside subsets. Maybe you use external registries as opposed to the internal registry. And Zarf kind of allows for a lot of that, like opt-in, opt-out feature development.
Cool. Thanks, guys. So to all of the viewers, if you'd like to just join this conversation, right? You don't necessarily have to be a maintainer, but there is a path to becoming a maintainer and contributing. Or you could be more like Dan, where you're contributing through feedback and use cases and stories. Those links are on the screen right here if you want to be able to hop in there. Next week, if you're in Atlanta, come hang out with all of us. Brant's going to be speaking all throughout the event. He's got a lot of things going on, but here's a key one that you should go check out on the screen there. And actually, just reach out to us ahead of time if you're going to be out there and you want to talk about stuff. Like, reach out. Then on the yep. Loads of other things happening inside of OpenSSF. So there's a bunch of different access points if you go to the OpenSSF.org website, or if you grab this deck and click on any links in it. There's the Slack, GitHub issues, mailing lists, loads of different things, including community calls that you can join and just ask questions casually. Social media, obviously, is a really good way to engage with OpenSSF and stay up to date with everything that's happening. And if you are a member, there's certain additional access privileges that you get as an organizational member. And if you liked this talk, fill out this survey. If you didn't like it, keep your opinions to yourselves. I'm just kidding. It would be really helpful if you guys just fill out the survey. Let us know how this went. And we look forward to doing this more in the future. Thanks, everybody. And thank you, Brant and Kit and Dan. Super, super informative and helpful. Thank you, everybody.